See? So this is the case for what? This is the case for positive MB, and the positive MB will lead to double curvature. So you can call that this condition is the condition for double curvature. Why? Because the sign associated with MB is positive. So this is the one for double curvature. Now with this reasoning process, how do we know to determine the location of the maximum moment for single curvature beam columns? It's very simple. You just replace the sign for the positive MB with negative MB, right? Because that's how we concluded before. When MB is positive, you're going to end up with a double curvature beam column. When MB is negative, you're going to end up with a single curvature. So the only thing you have to change is just remember this expression by changing the sign of MB. So if this is the expression for double curvature, the condition for the maximum moment in the double curvature beam column, and the condition for the maximum moment in the single curvature beam column will become something like this. For single curvature columns, we have tangent kx bar equals, everything is the same, except the sign with MB will be replaced with negative. So it's MA times cosine KL. Now it becomes minus MB and divided by MA times sine KL. So this is the condition for single curvature. Now, again, how do we find out the location of the maximum moment? Exactly the same thing. You have this, you plug in the value of MA and MB, but this time, when you calculate arctangent, you will have to use this expression. So that's why you have to be careful. That means Kx bar is arctangent of the whole thing. Negative MB cosine KL minus MB, not positive, not plus. MA sine KL, and consequently X bar is 1 over K arctangent of the whole thing. Divided by MA sine KL. So this is the condition for maximum moment in single curvature beam columns. Then how do you find the maximum moment? Just like what we showed before. And then you just plug the value of this into this. It becomes negative EI times Y double prime up X bar. And you already have the expression of Y double prime from before. So I trust you know how to find it, correct? Okay. That's the discussion about using the deflection to find the maximum moment this way.
Hey, Professor.
Yes.
Quick question.
Yes.
You said when the coefficient for MB is positive, it's double curvature. So in this case, isn't it technically positive because of that negative in front?
No. I mean, when we say the positive or negative, that's just a way to refer to the sign. The value of MB and MA will always be positive, as you know, right?
I think I'm muted. I can't hear you. I don't know why.
Am I muted? I'm not.
Yeah, we can hear you.
Oh, no, I can.
Can you hear me now?
Yeah, no, I can.
Okay. So what I was saying is, when you are provided with a problem like this, suppose you have a column and you're provided with moment like this. You'll always be provided with positive values. So you're gonna tell the people are gonna say that this is 20 Newton meter. This is 10 Newton meter, something like that. It is we have to define that which equation we're going to use, and the formulation choose one direction as a positive sign. So that's how we end up with this result. So the values of MA and B will always be positive. It is the sign, or in this case, the orientation of these M moments that you have to choose different equations to use. So in this case, or you can think about this way, when, because of our formulation, when MA and MB are in opposite signs, which is in this case, right? So you know that you will end up with a signal curvature. That means you have to use this one. You have to put a negative sign in this equation of MB. Would that make sense?
Yeah, that makes sense.
Okay.
Professor, on the exam, if we can use a shortcut and just use, like I was looking at the one you gave out last year for the last question, you have 1.5 P for a simply supported beam.
Let me see
Can we
it.
just use Euler's formula?
Which page you are looking at?
So it was the midterm sample you sent us, and then number 3, part B.
All right. Let me just open the file so we can all see this.
Oh, there's B.
Page 10. So, page 10.
So it's asking for PCR, and we know that P, or it's 1.5 P, and it's a simply supported beam, and that Q doesn't do anything to affect the critical load. So could we just say PE is equal to 1.5 P, and then is equal to pi squared?
Mm-hmm.
You can just do that. You don't have to do the whole thing.
Yes, you can. And I have considered that.
Okay.
So, yes.
Okay.
If I make the problem that simple, then you can just say that that's because of this, and this Euler's beam is simply supported. So the critical load has to be the Euler's load, which is pi squared EI over L squared.
Okay.
Professor,
yes.
about the exam too.
So you all cannot wait, right? All right.
I can't wait.
Yeah, shoot, go ahead.
I'm just wondering what the actual process is going to be. Like, how are we doing it? How are we submitting it? That sort of thing. I don't know if you're going to talk about that later, but I'd ask.
No. If somebody, if you already asked the question, sure, I will just answer that. I will try to use the Blackboard to submit it. But even that doesn't work, you can still send it to me. If you any case that you cannot submit it through the Blackboard, just send an email, put in an attachment, send it to me.
Okay.
Because I did it in the past, and there was no problem. No, I have abundant space in my email, so you can just send it to me. If you did send it to me, and I will eventually receive it. Okay,
so you'll like give it to us at the beginning of class, and then we have to submit it by 9.
Correct. Okay. And for those of you who have taken my structural dynamics in the past, or taken any of my graduate courses or even undergraduate courses in the past, you know my drills. What I will usually do is what? I will give out different versions of the exam questions. Because this is an online exam, right? This is basically take-home exams. Okay. But you should not worry about that. Having way too difficult questions to solve. All you have to do is to make sure you understand all the notes, and everything you need will be coming from the lecture notes. Whatever the question you're about to see next week will be something that we already talked about it.
All right.
Whatever the topic that I have not talked about, they could be on the textbook or it could be anywhere else. They will not be on the exams. It must be something here, and which you know that I am recording all the lectures, right?
Yeah.
So that means you have the proof. You have the evidence posted on YouTube, right?
Yeah, I've watched a couple excerpts on YouTube.
Yeah. So that means whatever the topic that you think that may not be clear, at least you can go back to YouTube and I don't know.
Yeah.
Fast forward to
I did
the
that for the
location.
first homework. So
just fast forward to the point that I talk about something like that, and you will have that last minute review, if you call it that, review during the exams. However, it is not wise to rely on that approach because you have 3 hours. If you want to figure it out during the exams, you know that that's
Not gonna work.
that's not gonna work. And besides, that's way too much pressure, right? And if you understand all the notes, all the problems, you should be all set for the midterm exam, because in this virtual online learning mode, we know that everything will have to be take home and open book, open note. And that's how I did with all my graduate courses. Everything is open book, open note. And in the end, I hope you will become open-minded.
Yeah.
Right? Everything's open. And I'm also learning, honestly, I'm learning in this process with this generation of internet. I'm surprised that there are so many different ways that people can exchange information.
Yeah.
So in this time of the civilization, you don't want to trade your place with me, because it's hard for me to tell that who is actually doing the exam and who is just copying from somebody else's. It's hard.
Mhm.
So I take instructors extra time and effort to figure out that who actually knows the material. And just keep in mind that the idea of exam is just to tell you that how well you have learned so far. That's the whole idea. That's why you're here. You're here to learn the material. If you understand the material, and you deserve to get an A.
Yeah, that's why I was curious, because I have I have been in your exams for dynamics and for inspection and monitoring, so I know the protocol.
Yes. Yeah.
And this is my first online course, so
Is my second one. So no, you think about it, it should be the third one. Okay, we should come back, right? It's 7:35, so let's come back. All right. Now, this will be step. Which step? This step actually takes way too long. So this is step 4, and that means this will be step 5.
Professor, the screen's still at the exam.
Yes. Thank you for the reminder. All right. And this will be step 5. In summary, we know that maximum moment, I will just give you the expression for single curvature versus double curvature. Maximum moment will equal to positive of the square root of ma squared plus 2ma mb cosine kl plus mb squared divided by sine kl.